joining me here today. In our previous video, we spoke about the current divider rule. In today's one, I'll take you through the voltage divider rule. Before I begin, what does it mean? What is voltage divider rule? Voltage divider rule is very simple, and it states that the voltage across a component of a series circuit is directly proportional to the resistance of that component. So we have two resistive components here which are in series. As you can see, I have R1 and I have R2. The voltage through R1 is VR1 and the voltage through R2 is VR2. Now from this analysis, voltage divider rule is stating that the voltage across this one is directly proportional to its resistance, and the voltage across R2 is directly proportional to its resistance. Remember that in voltage divider rule, we are dealing with what? Series what? Circuit. Alright, so another thing that you need to understand is that the current through this circuit is the same. Okay, if I find the current coming from Vs, once it runs through the circuit, it will circulate and it forms what we call a loop. Okay, so from here, let me label the voltage across the R1 as V1. And let me label the voltage across VR2 as V2. So let's assume that they are asking us to find V1. From voltage divider rule, the formula states that write your V1, the one we are looking for. So this is our V1. Now we go back to the source voltage or the supply voltage. The supply voltage is always directly proportional to that resistance the voltage we are looking for is passing through. Now we are looking for V1, which is passing through R1. So you first write your source voltage, which is the voltage supplying that side. So I'll write my Vs and then use it to multiply the same resistive value V1 is passing through. So that is what? R1. Now divide this result by R1 plus what? R2. This R2 is in the circuit, so use it to multiply. If we have another resistive value here, which is R3, you will add that result at the denominator. So now let's move on to what? V2. Now to find V2, it is the same process. Now you write your V2 equal to your source voltage, which is the one supplying Vs. Use it to multiply R2, which is the resistor V2 is passing through. So R2, divide your result by R1 plus what? R2. Now do you get it? Voltage divider rule is very simple. Very simple. Now from this analysis, it is very important that sometimes you need not to worry yourself to find the second voltage if you already know the first voltage. In the same way, if you have the value of the second voltage, you don't need to find the first voltage by using the same formula. All you need to do is to subtract this value from the source voltage to get the answer for V1. Or if you have V1, you can also subtract its value from the source voltage to get what? V2. That's what we call the Kirchhoff voltage law. So if I have Vs, which is supposed to be what? V1 plus V2, then if I know V1, I can find V2 by saying V2 equals Vs minus what? V1. In the same way, if I know V2, then I can also say that V1 equals Vs minus what? V2. So now let's put some values here and solve our first example. Now when you look at this diagram, I'm putting 2 ohms here and 3 ohms here. We have a source voltage or a supply voltage which is what? 10 volts. And they are asking us to find V1 and V2. To be able to do that, we just apply these rules. So the first thing we need to do, let's find V1. So V1 will be equal to, now we locate our source voltage, which is this. So let's put our formula. The source voltage Vs will multiply what? The same resistive value that is passing through R1, which is divided by R1 plus what? R2. Now let's substitute the values. We have Vs to be 10 volts, so we are going to get 10. So we have 10 times 2, all divided by 2 plus what? 3. Now when you solve this, we are going to get our V1 is going to give us 20 divided 5. which is going to give us what? 4 volts. In the same way, if we want the V2, we can just say that V2 is equal to what? Vs minus what? V1, which is equal to, we have our Vs to be 10 minus what? 4, which is equal to 6 what? Volts. Now, do you get it? In the same way, you can also use the formula to solve this by saying that your V2 will give you your source voltage Vs, which is what? Which is 10 times, know that the voltage is passing through R2. It is directly proportional. So we multiply by 3, which is this resistive value, divided by 2 plus what? 3. This is giving us 30 divided by what? 5, which is equal to 6 volts. So you could see that voltage divider rule is very simple. So now the next thing I'm going to do is that let me give you a full detail into the reason why the formula behaves like this. So we will prove this formula, try to understand it very well. Then we'll take our last example and we call it a day. Now we know that the voltage across R1 is V what? R1. And let's call the one through this one V what? R2. Now I'll be able to use this to explain it for you to understand. Now our Vs becomes what? V R1 plus what? V R2. Now we can now use Ohm's law to explain this formula. Now from Ohm's law, we know that the voltage source V is always equal to what? IR. Now you could see that if I have V R1 here, let us write this formula in terms of V R1. Looking for VR1, so I can say that VR1 is equal to my IR1. The reason why I didn't put 1 here is because current through this circuit is the same, okay, so I don't need to label it. Now let's write for this one. VR2 is giving us IR2. Now do you understand? So the voltage across the second resistor is this. You take the current, you use it to multiply. So I told you in the beginning that the current through this circuit is the same. So this is it, they are the same. So now let's label this one equation 1 and let's label this one equation 2. The next thing I'll do is that I'll take equation 1 and equation 2 and substitute it into what? Equation star. So now to do that, we are going to have our Vs is going to give us, now what is VR1? It is what? This, and VR2 is this, so we just substitute it there. So we are going to have IR1 plus I what? R2. Now when you look at this, we have a common variable here, so let us factorize what? I out. So now we have Vs giving us what? I outside into R1 plus what? R2. So from here, let us make I the subject, okay, of the equation. To make I stand alone, I will divide here by R1 plus R2 and divide this side by what? R1 plus R2. So I'm getting my Vs over my R1 plus my R2, giving me I outside R1 plus R2 dividing R1 plus what? R2. Now this one can cancel this. So we are left with what? I giving us Vs all over what? R1 plus what? R2. Now, from here, let's label this equation what? 3. The final thing that we'll do is that let's carry this equation 3 and replace it in either of what? Equation 1 and 2. So now what? If I want to find the voltage across the first resistor, which is R1, it is this formula. So I have my main R1 giving me what? I. This I represents what we have here. So we substitute it here. So we are going to have our Vs all over R1 plus R2 multiplying what? Our what? R1 here. Now we have an R1 here. So now when you solve this, the equation becomes Vs times R1 all divided R1 plus what? R2. So this is what? V what? R1. So now when you compare this formula with this one, you could see that they are the same. Okay, this explains the reason why the voltage across the first resistor is what? Like this. And the voltage across the second resistor is this. You can also what? Take the I and substitute it here into equation 2. And you are going to generate this formula, as simple as that. Now looking at this diagram, it is very simple, similar to the first one we did in the beginning. So when I want to find the voltage across R1, I just have my vein R1 will be equal to what? What is my source voltage? So the source voltage is what? 100 multiplied by the same resistive value R1, which is what? 5, divide the result by what? 5 plus 10 plus what? 15. So now when you punch this on the calculator, the result becomes vein R1 is going to give us 16.67 volts. Okay, so punch this on your calculator and get this. And correct me if I'm wrong. So the next thing that we will do is to find the voltage across that one. So vein R2 is going to give us what? The same source voltage multiplied by the same resistive value that voltage is supposed to pass through, because they are directly proportional. So we multiply by what? R2. R2 is what? 10. So divide this by 5 plus 10 plus what? 15. So vein R2 is going to give us, we have 33.33 volts. Okay, you can do the last one. Now remember, also in a complex circuit, once you can find the total resistance in the circuit, you will be able to find the current supplied by this circuit, which is I. Okay, once you are able to find I, the same I will flow through this, flow through this, flow through this. It is the same. So you can pick the I value, use it to multiply this resistive value to get the voltage across that without using the voltage divider. But if you don't have the total current, you can use the voltage divider to solve this. So in our next video, we are going to talk about the superposition theorem. How do we use the superposition theorem to solve or break down complex circuits? We are going to apply all these rules as we start those topics. If you haven't subscribed to this channel, please do. My name is Daniel. Subscribe to Twitter Think on YouTube and go to Twitter Think on TikTok. We also have Twitter Think on Facebook, Twitter Think 130 on Facebook. You can subscribe to our channels there, and please support this page by sharing.